Okay, so today we're continuing with the 7172 exponential functions, and our focus today is going to be the applications. So we're going to graph applications, and then we're going to do some computations with compound interest, which is one of the applications we talked about yesterday that model an exponential function. So the growth model and the decay model are very similar. If it is growth, you are adding the rate. The reason why the growth factor is 1 plus r is because 1 is equivalent to 100%. Okay, so you have what you started with in the 1, the 100%, and then that rate gets added to it. Okay, and then your exponent is going to be t. T represents the time. Your Y value is the final amount. A lot of times we'll be talking about money, so it could be a final amount of money in an account. A is the initial value, and then your R is a rate, but it's expressed as a decimal. So a lot of times the rates are given as a percent, and then you're going to go ahead and convert those to decimals. And then your decay factor is 1 minus R. Okay, so 1 minus your rate. Again, the 1 stands for your 100%. All right, so let's take a look at example 1. Okay, what I would like you to do is take a highlighter, and I want you to highlight the terms that you think you're going to plug into one of these variables. Okay, so when you find your initial value, I just want you to highlight that. Okay, and then if you want to put an A over it, you can. Try to find your R value. Okay, and then if you need a highlighter, I have some over there. Please cut yourself. Okay, so I want you to highlight those so that I can see them on your paper. Actually put the highlighter on your paper and highlight. All right, Rocco, give me one thing that you highlighted here. Yep, so just the 5,000, right? Because the 5,000 is going to go in for what variable? Nope. So she's investing 5,000. That's what she puts in at the start. Yeah, so that would be your A. All right, great. And then Nolan, will you give me something else that you highlighted? 6.25%. Nice. Okay, so the 6.25% interest rate. So that's going to go in for what variable? Thank you. Okay, now one thing we're going to label here is, like I just said, when you're putting in this value, you're going to put that in as a decimal. So remember that whenever you're converting a percent to a decimal, you go 2 places, to the right or the left. To the left. 1, 2. So it's 0.0625. So remember that from what's that? A while ago. It's hard to sit online. Okay, so yeah, it's like you're dividing by 100, right? So then you're moving it to the left. Okay, and then Titan, what was the last thing that you highlighted? Okay, 10,000. And then what do you think we're gonna do with that? It is great. Okay, that's your final amount. Okay, nice work. All right, now what this is asking you is determine how many years it will take her investment to be worth 10,000. So when they're asking you that question, how many years, okay, that indicates that you are going to find the value of T. Okay, and right now the only way we have to find that is graphically. Okay, so what we're going to do first is we're going to identify whether that is growth or decay. So anytime you're getting paid interest, it's going to be what? Everybody? That was most of us. Okay, and then so if you have growth, this is going to be your growth model. When you're plugging in your values to your model, okay, this is going to be step 2. You're going to leave the y equals because we are going to graph the function in this second step, okay? So I want you to plug in everything that you can into that model and write it down. And then, how many would you get for your growth model? Yeah. Did you say 0.0? Yeah, okay, 0.065. Great. Okay. Yes, into the power of T. Okay, so what you guys are going to be graphing is this. So you can add the 1 to that. Okay, that is called your growth model. So sometimes they might ask you, write a growth model. That's why I want you to label this. Okay. All right, and then for step 3, what we're going to do is we are going to use our graphing calculator to make a table. Okay, and you're just going to write down your points. All right, so I want you to go ahead, plug that into your graphing calculator. We are going to have large numbers here. That is fine. Okay, keep in mind because you are dealing with really big numbers, if you were to just graph this, you are not going to see anything on your graph because think about what happens if you plug in 0. If you plug in 0, what's your starting value? What's your initial value? 5,000. Right? So we're not going to see that on a 10 by 10 grid. Okay, so let's go to our table. Now, because we have a real world model, we are not going to graph our negative values here. And then you can decide what to go by. Sometimes what I do is I go by 5s. You're going to have to reach the 10,000 mark. You're going to have to go past that. So at 10, you're only at 9,000. So that's not enough. Sometimes what I do in my table set is I'll change it to go by 5s if I know that I need a larger number. So 0, 5, 10, 15, 20. Sometimes I do that one as well. Okay, so then at 5, And then does it really matter if I put the 0.4 on there? No, this is going to be so large you are not going to be able to tell the difference, right? So with these really large numbers, feel free to just round to a whole number. It rounds up, 68. Okay, so remember that we're trying to find how many years it will take for it to be above, or for it to be worth 10,000. So if you look at your table, okay, you have to make sure you go above 10,000. Based on our table alone, we should know that our answer is somewhere between 10 and 15 years, because from 10 to 15, it's going to cross that 10,000. Okay? All right, what questions do we have on this part so far? All right, so then when you are making your graph, if you want to go by fives, you do 5, 10, 15, 20, 25. Okay, this is the time in years. Okay, and then this is an account, so this is going to be the balance in the account in dollars. Okay, and I do want to at least get up to the 16,000. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I go by 2,000, then that should be enough. I'll put 8,000, 10,000, 12. It doesn't matter if you want to put the K for the 1,000 or write it out. Either way is fine. Okay, and then we are going to plot those points. Okay, so at 0, I'm at 5,000. At 10, I'm close to 9,000. And yes, these are going to be estimates. So 12,400. At 20, I'm at 16. 09, so almost 17. At 25, I'm actually really close to that. 22. Okay, so that just helps me create my curve here. Okay, there is like a gentle curve that's happening on your graph. All right, and then our last step is we are going to estimate using the graph. Okay, so some of your problems are going to tell you to graph, and then so you do need to make a graph like this. When that happens, and you're trying to estimate 10,000, usually what I'll do is I'll just highlight what that line is. Okay, that is the line y equals 10,000. And then from there, how can you find approximately what the time is? What are you looking for? Yeah, where they cross. Okay, so you're looking for the intersection point. Okay, which on my graph is here. Yours might be a little bit different. So we went by fives. Okay, so halfway. It looks like mine's going to be about how many years? Yeah, it looks like it's about 12 years here. We're going to find the exact value on the calculator. Okay, so find the intersection. So in your Y1, you're going to put your growth model. It should already be in there. In your Y2, you're going to put 10,000. And then we have used the intersect feature before. You can go to second and then the trace button. And there you will go to option 5, which says to intersect. Okay, so in order to do that, you have to make sure that you are graphing in the correct window. Okay, so once you plug in 10,000, you already made a graph on paper, so that is your window. So when you are changing your window, just use the same exact values that you put on the graph that we just did together. Okay, so your minimum for X is 0. So as a reminder, if you just go here to your window, you can change your X. You can go 0 to 25 and you can go by 5s just like we did. Okay, your Y min is 0. Our max, we went up to 25,000. Okay, and we went by, we really went up to 22. And then we went by 2,000s, okay? And now when you graph, you should be able to see that intersection of lines. And then we're going to follow these directions, okay? So we're going to go to second, the trace button. You can just press 5 for the intersect. And you may remember you just want to get right on that curve. Okay, so enter, enter, what's your guess? Okay, so based on your intersection, X is 11.4. We're just going to round to the nearest hundredth there. Okay, so X is 11.4 when Y is 10,000, which means your final answer is going to be 11.4 years. Okay, so really, our graph was pretty good. Okay, 12 years is in the ballpark, especially when you're doing it by hand and you have such a large margin. Okay, so based on what we did in example 1, I want you guys to start example 2. So I want you to start the same way. I want you to highlight any value that you're going to plug in for one of those variables. And then let's see if we can write our function. And then we'll check that together. Would you like me to charge it by you? Okay, so this is the city population was initially 15,500, and then notice that they say it has been dropping by 3% per year. So if it is dropping, we should use our decay model. Okay, so that's y equals a, 1 minus r to the power of t. Okay, so they gave you that key word for initially. All right, so we put the 15,500 in there. All right, and then Natalie, how did you write 3% as your decimal? Good. Okay, so when you're doing 1 minus 0.03, you can just think of it as 100 minus 3. 100 minus 3 is going to be 97, so this is going to be 0.97. Okay, so when it says write an exponential function, you should have an input variable and an output variable. The input variable is t, the output variable is y. Okay, so write an exponential function. This is your exponential function. This is your decay model. Now we're going to graph the function. Okay, so whenever you graph the function, I just want 5 points on your XY table. Okay, and then this is set up as parts A, B, and C. When you have to graph a function, if there is another part, I would look at that to determine what you want to go out to. So it says to use the graph to predict when the population will drop to below 8,000 people. So as I am filling out my table, I do need to keep in mind that the y values have to go below 8,000, or else I'm not going to see what I need in order to get the correct answer for part C. Okay, so we're going to start with our model. I cleared out the last one. So we have 15,500, 0.97 to the power of x. Again, we can go straight to the table from there. I still have mine going by 5s. Let's see if that's enough to dip below 8,000. Yeah, right there at 25 is when you can see a value that's below that. So I'm going to do 0, 5, 10, 15, 20, 25. Okay, sometimes you might not have to go out that far. So if you want to go by 3s or 4s or 2s, you can do that just depending on your situation. Okay, and we can use our table to help us come up with these values. And again, because your numbers are large, it is fine if you just round to the nearest whole number, because it will not be a visible difference on your graph. Okay, so using the table is a great way to see if you are going to solve correctly, because based on my table, I know that my answer should be somewhere between 20 and 25 years, okay, when I get to part C. All right, so again, let's see, I have 5, 10, 15, 20, 25, so I'm going to go by 5s again. Okay, and then I started 15,500, so I have to at least go to 15,000. So I'm going to use the same strategy I did last time, and I'm going to go by 2. So 2,000, 4,000, 6,000, 8,000, 12, 14, 16, 15. And then I'm going to plot those points from my table. So at 15,500, I'm almost to 16. At 5, I'm at 13. So 12. At 10, 11. 15, I'm almost to 10. All right, and then again, we're just gonna connect this with a slight curve here. Okay, and there is a margin of error when you're doing this yourself, so that's okay. And then you are gonna find the intersection between these. Okay, so we're going to use that graph. Again, we're going to use our graphing calculator so we can get the most accurate value possible. So we're going to put in our decay model. Should already be in there. And Y2. Okay, it's asking you when is it going to dip below. So in my final answer, I'm going to say after however many years, because when you find the intersection, at that intersection is when it equals 8,000. Okay, we want to find when it's going to be below 8,000. Oh, and for your graph, this is your time in years, and this time your Y is the population. Let's say population, people. Okay, so I have 8,000, and then you can really keep the same window that you did last time, 0 to 25, going by fives. Okay, max, did you 25,000 or 20,000? Okay, and then again, I went by 2,000. Okay, so you should be able to see the intersection there. Okay, if you need to adjust, like if the x's aren't far enough, you can do that, but we can see them here. So I'm going to go to second calc. We're going to intercept. The nice thing about the intersection is the first curve, second curve should be right next to each other, so you can press enter that 3 times. And again, we'll just round to the nearest tenth. Okay, so it says 21.71. So after 21.7 years, and that does fit in with our table, which said it would be between 20 and 25. Okay, and then let's see if our graph was accurate, the graph that we did by hand. Okay, so it looks like my intersection point's about here. And this is 22.5, so yeah, I would have probably estimated about 21 years, so that's pretty good. Okay, what questions do you have about solving by graphing? All right, then let's calculate some compound interest. So some of you have found this before in other classes. Do you guys do compound interest in one of your econ classes? Okay, so I want to know if you use this formula. So this is A of t equals P times 1 plus R over N to the power of N times T. Yes or no? Yeah. There's another one too that we'll learn later called PERT. P-E to the R-E. Okay, and it's okay if you've never seen it before. I'm going to teach it to you like you never have. Okay, you'll just have a leg up if you have used it. Okay, so this is A of t, and A of t, or A, is sometimes abbreviated as A. Okay, that is the amount after t years. Okay, so how much is in an account after t amount of years? Do you guys know what P stands for? Yeah, but the P word is principal. Okay, so that is your initial amount. Yes, it's your starting amount. It's your starting value. Okay, and then your R is still the rate as a decimal. So you're always doing that conversion, okay? All right, and then the value of N might be new for some of us. This is something that we'll talk about. This is the number of times, okay, the number of times per year it's compounded. Okay, so the interest gets compounded, and then N is the number of times per year it's compounded. Okay. All right, and then the T is still your time. All right, so one more time, I want you to grab that highlighter, and in example 3, I want you to highlight the values that you are going to plug into the equation for a variable. Okay, you can just do it in the example. So as I read it, you highlight. Okay, Seiko deposits $3,500 into an account. Find the balance after 8 years for each of the following scenarios. Round to the nearest cent. Okay, money is always rounded to the nearest cent, so even if it doesn't say that, you need to do that. Okay, the nearest cent is how many decimal places? Thank you. Okay, so the nearest cent is 2 decimal places. Okay, so we have this 3,500 that we should have highlighted, and then this 8 years. Okay, I want you to put the variable above that we're going to plug that in for. Okay, and then for A, it says the account pays 5.8% annual interest compounded monthly. So from that, we are going to be using the 5.8%. We're also going to be using the compounded monthly. All right, so your 3,500 is your principal, so that should have a P above it. The 8 years is your T for time. Okay, the 5.8%, that is going to be your value for R. And then the monthly is going to be your value for N. So remember for N, it's the number of times per year it's compounded. So how many months are in a year? 12. So N is going to be 12. Okay, so for part A, I want you to write the rate as a decimal. And then N is 12. And then go ahead and plug those values into this equation. Okay, so you're going to plug in the P, the T, the R, and the N. Alright, looks like we're doing a nice job at converting. Okay, so you can put 0.0 or you can just do 0.058. Again, we're just moving that twice to the left. Alright, so then you have 3,500. 1 plus 0.058 divided by 12, and that's to the power of 12 times 8. I'm just going to put a star for multiplication here, so you don't think that it's a decimal when you're looking back at it, okay? And then I'll show you how to plug this whole thing into your calculator. You are going to need to try this to make sure that you know how to plug it in correctly. So you can do the 3,500, the 1 plus, and then some calculators need this in parentheses to show that you need to do that first. Others you won't have to, it just depends. Okay, same thing with this. So if your calculator does the exponent like that, you don't have to put it in parentheses. But if your calculator does not, and it does the caret, then you do have to put that in parentheses there. So take a moment to plug that in. to quit out of your graph. And then if you are having trouble getting that decimal, I will come around and help you with that. Okay, so don't put it into your y equals, okay? You don't need to. If you do put it into your y equals like this, it's just going to give you a straight line, and it's going to be at 5,560.26. All right, and then when you're ready, why don't you go ahead and try B. So let's see if you guys can identify your R and then the value for N. Okay, so you are always moving your decimal 2 places. Okay, so if you have 0.75, if you go 1, 2, you have to put a 0 in as a placeholder. So you should have 0.0075. Okay, so if you have 0.75, it's 1, 2. Okay, and you're going to put a 0 in there. All right, for quarterly, it's how many times that's compounded in a year. So if it's quarterly, do you know what that is? 4 times. Okay, you can think of it like how many quarters are in a school year, right? There's 4. Okay. It might ask you, sometimes it asks semi-annually. Do you guys know how often semi-annually is? Twice. Okay, like a semester. Okay. All right, so if it's quarterly, it's 4 times per year. You guys know how many weeks there are in a year? 52. And if they ask you days, just do 365. As opposed to 365 and a 4. Right? Because of the leap year. All right, and then let's go ahead and round that to the nearest cent. So I'll give you a moment to do that, and we'll see how we do. Oh, actually, I'll show you something cool, which you might already know. But on some of the calculators, if you go and you highlight this and press enter, it'll do this value again. So then you can just go to second insert. You can make it 0 and then 75. Some people just think it's, and then you can delete things. Some people think it's easier to start over, and that is valid. Okay, and then I would just put in the 4 times 8, you know, is 32. Okay, so this one did not grow as much as the other one, but that makes sense because what had the greater interest rate? Part A. It was also compounded more frequently. The more frequently it's compounded, the better it is for the return on your investment. Okay, so because you're doing applications today with your story problems, I'm just going to have you use a regular sheet of graph paper. And if you need one, I will pass that out to you. And then I'm going to put up your assignment.